Here's problem 34.1. The Earth is 1.49 times 10 to the 11 meters from the Sun. If the solar radiation at the top of the Earth's atmosphere is 1340 watts per meter squared, what is the total power output of the Sun? All right, let's imagine we have the Sun. Let's put out power, and we're going to be some radius away from it. So here's the Earth, blue Earth, and the distance from the Earth to the Sun is 1.49 times 10 to the 11 meters. Now we can imagine that all the Sun's energy is being distributed over a sphere of radius r. So it's being three-dimensionally distributed over this sphere. And we recognize that here on Earth we are receiving an intensity of 1340 watts per meter squared. We know this is an intensity because of the units. Units are given as watts per meter squared. It's got to be power per area or intensity. Now we know that power should be equal to the intensity times the area. And if we're receiving this kind of intensity at the radius away from the Sun where the Earth is, that is the intensity that should be at the that radius in all directions from the Sun. So the power we're talking about being put out by the Sun is this intensity over a sphere of area 4 pi r squared. So that is going to be 1340 watts per meter squared times 4 pi times r, which is going to be the radius of this sphere, 1.49 times 10 to the 11 squared. So what is that? 1340 times 4 times pi times 1.49 to the 11 squared. I get 3.738, we'll say 3.74 times 10 to the 26, and that will be watts, joules per second. So that's the power output of the Sun based on what we're receiving at our distance from the Sun at 1.49 times 10 to the 11 meters. 3.74 times 10 to the 26 watts.